So we just did an example revolving about the x-axis. Let's try one revolving about the y-axis. So part B, we're going to take y equals 1 minus x squared, where x is between 0 and 1, and we will revolve about the y-axis. Okay, I highly recommend you start any of these by looking at a graph. And so I've got some notes here, but I kind of point your attention to my graph. So, right, y equals 1 minus x squared, that's the parabola pointed downwards. It passes through 1 here at the top. It also passes through 1 and negative 1 on the x-axis. But we're only looking at the segment between 0 and 1, so that guy right there. But that curve, that arc, is going to spin about the y-axis to create that surface area. Okay. So as you're looking at this and you're thinking, oh gosh, spinning about the y-axis, if you remember techniques from Calc 1 when we were doing volumes, the first technique that we learned, if we were rotating about the y-axis, then you had to convert everything, think of it the opposite way, and integrate with respect to y, right? So you had to solve your equation for x, and you had to just rethink how you were going to go about that integral. Turns out with surface area, you don't have to do that. If you're revolving about the x-axis, you can still integrate in terms of x. Okay, why is that? Well, you kind of see my note here. Now the radius, you always start to draw the radius, you always start on the axis of revolution. So if that's the y-axis, then we're going to go there, and then we're going to go out perpendicular until we hit our curve. We can find this length, we can still find that in terms of x. That's not a problem. And we know the boundaries on x are 0 to 1, right? We can still take our derivative of our function with respect to x. It's all going to fit. It doesn't matter that we're revolving about the y-axis. And you kind of think, even deeper, like, all those little line segments that would add up, all those little frustrums of all the cones, right? Well, if we think, they're all kind of these little pieces inside there, right? They're all spinning around making this little. We can do that all with respect to x. That's not a problem. Okay. So let's go about it. There's our function, right? F of x equals 1 minus x squared. So a derivative, very nice here, negative 2x. We square that, we get 4x squared. So we know f prime of x squared. Now, all that's left to set up the integral is to figure out r of x. What is that length in terms of x? And in this particular case, it can be so simple that it's confusing, which is not uncommon in math, as a matter of fact. What is that length in terms of the x value that we're looking at? And, well, it's simply that same x value. Here, r of x just equals x. Okay, let's talk about that a little bit more. Let's say we're looking, at the very bottom of this arc, and we're thinking of the very last little piece spinning around. Well, what's the radius right there? Well, it's 1, isn't it? What if we're at the very top? And that's part spinning around. What's the radius? Well, it's 0, isn't it? And that's the x value, and 1 was the x value. And anywhere in between, wherever we happen to be looking, well, the x value tells us how far we are from where we revolve. So r of x simply equals x. So simple it's confusing. Okay. Let's see if we can get some of this on the screen. So when we set up our integral here, surface area equals 2 pi integral from 0 to 1. There's r of x, square root 1 plus, there's f prime of x squared, 1 plus 4x squared dx. And now we just got to think, okay, are we going to be able to figure out this integral? And yeah, here it's just a u sub right away. There's not even any simplification to do. We're just going to go right for the u sub. Let's just see all that. So u will equal 1 plus 4x squared. So du equals 8x dx. We don't need that 8, so let's divide it over. 1/8 du equals x dx, right? We got the x dx covered. Okay. So surface area. The 1/8 we're just going to pull out in front and make that pi over 4. Integral 0 to 1. And then the x dx becomes our du. And okay, square root of u to the 1/2. All right. Imagine you guys you're forced to really hone your u substitution. We see it so much. Get a lot of practice with it. Okay, taking an antiderivative here, pi over 4 times 2/3 u to the 3 over 2. This is from 0 to 1. We'll replace the u with 1 plus 4x squared. Let's go ahead and simplify those fractions as well. There we go. And now we can plug in. Plugging in the 1 would give us 5. So pi over 6 would be 5 to the 3 halves. Plugging in 0 would be 1 to the 3 halves. So there we go, minus 1. And at this point, grab your calculator, finish it off. Surface area here is 5.33. Okay. Let's stop this video here. One more example to come.